Okay, so this is problem number 28. A 7-gram bullet is fired into a 1.5 kilogram ballistic pendulum. The bullet emerges from the block with a speed of 200 meters per second, and the block rises to a maximum height of 12 centimeters. Find the initial speed of the bullet. Okay, so the first step here is to draw a picture. And we're going to draw two pictures actually. One before the bullet hits the pendulum and one after. So this is the bullet. It's 7 grams, but we should convert that to kilograms because that's what we need to use in our equations ultimately. And then the pendulum is 1.5 kilograms. And in our second picture, the pendulum is swinging. And the bullet has exited the pendulum. It's going forward 200 meters per second. And the block rises to the max height of 12 centimeters. Okay, so we can just indicate that like right here. And then once again, it's important to convert to meters because that is what we will be using in the equations. All right, so first, we kind of have to work backwards. You start with the potential energy of the pendulum at the top of its swing. So at the top of its swing, the potential energy is going to be U equals mgh. And then we would plug in, so the mass would be 1.5 kilograms times gravity, so 9.8 meters per second squared, times the height, which is given 0.12 meters, and then that comes out to 1.764 joules. Okay, so using this information, when the pendulum is moving with the bullet, it has kinetic energy, and so we're going to set up a kinetic energy equation here. So K equals 1/2 mv squared. Okay, and since energy is always conserved, this potential energy at the top must equal the kinetic energy of the swing. So we take this number, plug in 1.764 joules equals 1/2, and then the mass, since the bullet is in the pendulum, it would actually be the mass of the pendulum and the mass of the bullet added together. So that comes out to be 1.507 kilograms. And then times the velocity squared, which we do not know. Once you solve for velocity, it comes out to be 1.53 meters per second. And so once we have this velocity, we need to go back to the original collision between the bullet and the ballistic pendulum. So when the bullet collides with the pendulum, the momentum is conserved. So we're going to set up our conservation of momentum equation. So m1v1 plus m2v2 equals m1v1 final plus m2v2 final. Okay, so m2 is 1.5 kilograms, but keep in mind that the pendulum starts at rest, So V2 is actually 0, and so this goes to 0. And then plugging in from our givens, 0.007 kilograms times V1, which is what we are ultimately solving for, equals M1, so that's 0.007 kilograms again, times V1, V1 final, which we just solved for up here, so it's 1.53 meters per second, plus, or actually, I'm sorry, so this would actually be 200 meters per second. It was given because the bullet emerges from the block with a speed of 200 meters per second. And then here, the mass of the pendulum is 1.5 kilograms, and then the final velocity of the pendulum, which we just solved for, would be 1.53 meters per second. And then solving for V1 over here, you end up with about 527.8 meters per second. And that is how you do problem number 28.